his idea. I do. I really do. I mean, we can easily make confidence intervals around L1 and L2 and then compare them. And I don't think we even have to. You can look at those two and say that they look like they're about the same. I mean, there's definitely some differences in the data, but I think on average they're about the same. The problem, as we just said, is there's going to be a confidence problem. And there's also an underlying problem that we haven't even talked about. Jolene, again, there's an underlying problem. I know what it is.
When peak volume occurs.
Oh, that's a data good. So Jolene's brought up a very, very important, and this is what I want to test myself when I have the time, is this is peak volume, not say average volume. So you might be watching a show that's like a murder mystery, very quiet, and there's a gunshot that goes off, and it's done like in that crazy Lucas sound thing that's supposed to like get your attention and make you jump. And that might be the peak volume right there, which might not be indicative of everything else that's happening at that time. So that's definitely a limitation of the data, which is why I want to do it myself with average volume. Thank you. Very, very good. Very, very good. I'll fix that someday. So let's live with peak. Let's live with peak for now. Okay, we'll come back to my question. Can we collapse this data so it's all in one data set? What do you think?
It feels wrong, but it feels wrong. I did it, but it.
What did you do?
I don't remember.
You said it feels wrong, though. You already flushed it out. It couldn't be right. I forgot what I did. I didn't even say anything, Sean. Stop looking at me.
Yeah, I should have the number 8.
The number 8. Where did 8 come from?
T interval.
You did a T interval on... Oh, sorry. I'm getting excited. Maybe you guys have ideas. I'm sorry. I do, because I love your guys' ideas. So I love the T interval, but the problem is, unless we can run both of those at the same time, we're going to lose confidence. Right? Mel, got an idea? I love that idea too. So we have a question over here. Is there's something called a 2-sample t-test, when you actually have 2 samples of data. I love that too. But here, I'm going to answer that question with a question. Do we really have 2 different samples here? So this is what I want you to think about. Or is it 1 sample that has 2 measurements? So here's what I'm saying. What we did was, we measured the volume level of a show, and then we measured the volume of the commercial immediately after the show. And the reason I'm saying that's important, how many of you guys seen the movie City Slickers? It's an old movie, 97 I think, 95, 97. Yeah. Billy Crystal's character in there sold advertising space. That was his job. That's what he was having his mental breakdown, his midlife crisis during, sell advertising space. Basically, I sell air. It's a great movie. But it got me thinking, they have to be very specific about what commercial they put with a certain show. For example, if it's an action show, you probably don't want to have like chamomile tea as like a commercial. You're feeling wrong. Maybe you do. But there's like rules for what commercials go with what shows. There's a pairing. So what I want to do is I don't want to lose that pairing. If I make it 2 samples, 2 separate samples, I'm admitting to myself that the shows and the commercials aren't tied in any way. But I think they are tied. I think they're tied by the fact that whatever the peak volume here is going to be, should be, if it's properly set up, tied to this commercial. You see my logic there, friends? So is there a way to maintain that tie and just say, oh, okay, so this is 1 show. Is the commercial louder here? To the nearest decibel? No, they're both 72, yeah? How about here? Is the commercial louder? It's actually 1 decibel lower. How about here? 1 higher. How about here? 2 higher. FYI, these are decibels, and you might think that 2 decibels isn't that much. Do you know what a decibel is, or how they measure decibels? You know why it's called a decibel? Each step up is 10 times more intense than the one below it. Same way they measure things like hurricanes and tornadoes and earthquakes and things like that. So every jump in decibels is 10 times more intense, and I think they measure the sound waves or something like that produced. I know in my band, we were once clocked at 118 decibels at our loudest part of a show, which is, I think, to sound like a small airplane taking off. I was very proud of that. That's why I break so much crap out of the drums. So a jump of 2 decibels might be aurally, A-U-R-A-L-L-Y, significant. Fair?
Yeah.
So, I think you guys just discovered the answer. What can we do with these numbers?
Find the difference.
Is that what you're going to say, Ma? I saw your hand go up about 2 minutes ago. Is that what you're going to tell me?
Yeah.
Sister, thank you. Yes, find the differences between the shows and the commercials. Does that make sense? So what do you think we should do? We're trying to see if the commercials are louder, right? So we want these numbers to be bigger than their corresponding numbers over here. And the reason I'm bringing this out of I love your idea. I want to make sure we subtract them all the same way. So do you guys want to do the show minus the commercial, or the commercial minus the show?
Commercial minus the show.
I think that makes the most sense, because if we do that, we should get predominantly positive numbers if they're louder, correct? Is that believable? We should get predominantly positive numbers if we subtract them that way. Yeah, I think so too. So, don't do it one by one. Watch this. This is slick. Your TIs actually have some slick capabilities. Just they can't. So put your cursor on top of L3. You see where I put my cursor? I got stuff that I'm going to clear it out. So put your cursor on top of L3. So it's sitting up and it's highlighting it right there. And then I'm going to zoom this in so we can see it better at home. There we go. So now all you're going to put in is L2 minus L1. So second 2 minus second 1. And what this will do is, when you press enter, it'll just rocket through and take all those differences for you.
Wait, how do I get down there?
How do you get down where? There they are. There are your differences. Boom. I mean, you can do it by hand, of course. I mean, but this is much more efficient. Yeah. It's like using Excel. Every once in a while, your TI does something, it's like, oh, cool, they thought about that in 1986. Yay. In 86, it was cool. Now it's like, Fair? So, why does this make me so happy? Because we now have one data set we can analyze, don't we? We now have one data set. And the data set is just looking at the differences. So our data is just going to be the differences in decibels, that's dB, decibels, between the shows doesn't have an N, and the commercials.
Mine gave me an error. How did you do that again?
What error did it give you? What error did it give you? Which error? Syntax? Oh, you got it. Vernon got it. Fair? So, let's make sure we understood what we did. You've got what look like two different sets of data, but they're tied to each other. Each of those commercials is paired with its show. It's married, if you will, to its show. So there's what's called a dependence between them. I love two-sample t-tests. I'm not saying they're useless, but they're very useful. We'll start them on Tuesday, and we'll start looking at different types of byte breaks and how they perform. Very important. But when they're tied in some way, you can't treat them as independent, and vice versa. Fair so far? So now here's my question. What are we now going to analyze with that column? If you scroll down, you can see all your values.
We need a total, if it's a positive or a negative.
Total what?
The total,
Oh, so you add up the entire shebang.
well, on L3 to see.
Add up L3 to see if it's... Okay, I love that idea. I'll do this real quick. You don't have to worry about it, because what you've given me, Frankie, is correct, but the TI will take care of it and other stuff. But I will do it for us right now. Love the point,
How do
though.
we do that?
Don't worry. You won't have to do this, because your TI will do it for you automatically. But if I sum up L3, I get a positive 9. Okay, so positive 9, that's a positive number. And we said if the commercials are louder than the shows,
So the commercial
they should be positive, right? So that's positive. You can't really see that, I'm sorry. 9. So the commercial's louder than the shows.
Right. Well, according to this.
Well, but what haven't we done? What we've done is we made the classic media mistake. We said, oh look, that's positive. And nobody stopped to ask, is it positive enough to be... Ah! Damn it, rule. You got me again. Sorry. So it's positive, yes. So we know we're in the right neighborhood. But now the question is it super positive, like statistically positive, or is it kind of positive? Technically speaking, we should divide that by 23 too, shouldn't we? To make it an average. So it's still positive. But the question is it positive enough to be statistically significant? And that's the question we need to answer. So let's deal with this in a hypothesis test. 10 steps. Boom, 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 boom. Fair? Danielle's like, oh, I was out of this earlier. You've done all the hard work. You've done all the hard work already. I mean, you've taken care of everything. We have to answer one more question, and then we're ready to process. So we haven't addressed the margin of error issue, which is what we have to deal with.